Hi everyone. Uh, in this video, we are going to look at how to graph linear equations. We have 5 learning objectives. First of all, we look at if a given pair of numbers is a solution to an equation with 2 variables in it. Then second objective is to find 3 sets of solutions for a given equation in 2 variables. This is our foundation to to graph the linear equation, which is a line. And then see in the third goal, we are going to graph that linear equation in XY coordinate system, 2 unknowns. And then learning objective number 4 is a special case of linear equation. We have horizontal lines and vertical lines. Finally, we're going to look at how to find x and y intercepts if we are given an equation, because the graph of the equation will intersect with the axis in the coordinate system, and we want to be able to identify the x and y intersection points. Okay, let's do it one by one. First, how do we determine whether a given ordered pair is a solution to an equation or not? So this description actually is very simple. All you need is to replace the variables in the equations. In the equation, in this case, we only have one equation to see if both sides are equal or not. If both sides are equal, then you get a solution. If both sides are not equal, then the given pair is not a solution. So let's look at our first example. So determine A and B. Let's focus on A first. Determine whether the ordered pair is a solution for the given equation. So ordered pair, ordered means the first one is always x, the second one always y. So we just replace x with 2, y with -5, and do the calculation. 3 times 2, usually I put the value of variable inside parentheses, plus y is -5. Let's do the calculation. If this results in 1, which is the same as the right-hand side value, then we get a correct solution. Otherwise, this is not the solution. So 6 plus -5, and that is 1. So there's a checkout. So the answer is yes, the given ordered pair is a solution. Now, as I just said, is a solution, right? Because for a linear equation with 2 unknowns, we have infinitely many solutions actually. And this is just one of them. So second one, same kind of question, we need to see if this ordered pair is a solution for this equation. So plug in y equals, y is -7 equals 2 times x -4 minus 1. If again, if this is a question mark at the moment, if they're equal, it is a solution. If it is not equal, it is not the solution. -7 equals -8 minus 1. What is a -8 minus 1? It's -9. So this is not equal. The answer is no. This is not the solution. So the idea is very straightforward. You just plug in to see if both sides are equal or not. Now we get another one, determine this ordered pair is a solution or not. Nothing really different. The only difference is that we get decimals and fractions as the ordered pair, but the way we do it, it remains the same. So y is a 3.5. Put on the left-hand side because this is the y, this is the y value. And 3/2 times x itself is -1/3. then plus 4, right? Now let's do the calculation. Let's see if they are equal or not. When we multiply fractions, we try to simplify them first. So these two cancel out. We get negative 1/2 because we only have one left on the top. This is the 1, this is the 1. And we have negative 1/2 plus 4 is equivalent to 4 minus 0.5. And this is 3.5. 4 minus 0.5 is 3.5. So the answer is yes. This is the solution. Now, our second learning objective, find 3 solutions for an equation in 2 unknowns. See, how many solutions are there for this particular one? This is just a basic idea to show people, to demonstrate that for a 2 unknown equation, we have infinite many solutions. So let me give you some. If x equal to 1, y equals 4, 1 plus 4 equals 5, right? So this is the solution. How about 2 and 3? Right? How about 3 and 2? How about 0 and 5? How about negative 1 and 6? So how many ordered pairs are the solution to this equation? Infinite. The reason we want to find 3 solutions for an equation, this is the foundation for us to draw the line, because the graph for a linear equation is called the linear equation. Whenever you have variables in the equation where the exponent for each variable is exactly 1, no matter how many variables, that's called the linear equation. For 2 variable linear equations such as this one, the graph is a straight line. To draw a line, basically all you need is 2 points that belong to that line, because one can only draw one line, unique line, go through those 2 given points. There's no second line. So in logic, in theory, you only need 2 points to connect to get that line. But why 3 then? 3 pairs, each pair is a point in the coordinate system. If you watch my last video, you know that already. So we need 3 pairs, but why 3, why not 2? Is 2 if 2 pairs is enough, right? The third one, like checkpoint, the third pair, because if all your calculations are correct, all the 3 points will be on the same line, no matter how many points. If your calculation is right, they're all on the same line. And what if one is wrong? If one is wrong, there's no way you can draw a straight line through the 3 points. So by having the third point, third solution, you're doing like self-check to see if all of your calculations are correct. Okay. Now, this is our example, find 3 solutions to an equation. The way to do that is that between these 2 variables, you just assign a number to one of these 2. Any number is okay. The reason is that a line can extend in both directions to infinity. There's no end in either side. That means horizontally, it can go to infinity. Vertically, also it can go to infinity, which implies x can be any value, y can be any value. But the thing is that you cannot choose 2 random numbers. One is for x, one is for y, because your numbers has to be solution to this equation, which is a line. In other words, equivalently, in terms of graph, your solution to the equation will be a point on the line. If you randomly choose 2 numbers, you get a point, that point is not necessarily on the line. To ensure the point is on the line, you randomly select one number for one of these 2 variables, you calculate the other variable. You calculate the value for the other variable. No matter you randomly select value for x or y, if you randomly assign a number to x, then you calculate y. If you randomly select a value for y, which is totally fine, then you calculate the value for x. Either way is okay, depending on which one you want to do, which one is easier to do. So I'm going to do this one. So I just let, say, for example, I let x equal to 0. I just let x equal to 0. Because x can be any number. If x is 0, I plug in, this is gone. It says y equal to 5. So I get one pair, 0, 5. Then if I let x equals 1, plug in here, this is going to be 2. 2 plus 3 equal to 5, right? And y will be 3. Okay, another one, another pair. So this time I do something different. I let x be equals -2. Now let's do the calculation. 2 times -2 plus y equals 5. -4 plus y equals 5. Plus 4 on both sides. So y equals 9. So then y equals 9. -2 and 9. So I get 3 pairs. Then if your graph is the 3 points in the coordinate system and connect them together, as long as your calculation is right, we will get a straight line. Now let's look at example 4. Same question, just different equations. Find 3 solutions for this equation. Now, the reason we have this one is that we have a fraction in front of x. In theory, again, x can be any number. Actually, it can be any number, whatever you want, it's still going to work out. But if you draw the line manually, there's a problem here because it's not every number for x that can be divided by 3 evenly. If you select some number for x that result in countless decimals for this part, then your y will also have countless decimals. That means you have to round it. That means you have a rounding error before you even draw the graph. So usually we want to find the solutions. This is just finding solutions. It's not about drawing the graph. But the very reason we find the solution is to draw the graph. But in theory, again, you can choose any x value, plug in to calculate y. But for the purpose of making this calculation easier, because x can be any value, why not choose those that is easier for the calculation, right? That makes sense. I choose those x values that are multiples of 3. So that when you divide by 3, you get a whole number. So first what I want to do, I want x to be 3. So now let's look at y. Y equals 1/3 times 3 minus 5. This cancelled. 1 minus 5, -4. So I get 1 pair, 3 and -4. See, I get a nice whole number, right? Now, next, I let x. Surely you can let it be 0. That's the best, actually. Y equals -5. 0, this whole thing is gone. So 0, -5. Let's do one more. This time, I let x equals -6. Then y equals 1/3 times -6 minus 5. Cancelled, get 2, -2. 1 times -2 is -2 minus 5, -7. Then you have -6, -7. So I get three pairs of solutions easily. We don't even need a calculator. Okay, now finally, we are going to look at how to graph linear equations in x and y. Look at the first 4 letters in this word linear. What's the word in the first 4 letters? That's a line, right? So linear equation means whose graph is a line. Okay, now basically it says find at least 2 solutions, which means 2 points is enough to draw a line. But if you use the 3rd point, you get insurance to double check your calculation if they are all correct. Then you plot those points in the coordinate system, then connect them together through a straight line because it should be a straight line. So let's look at this particular example. We want to graph 2x plus y equals 5. First of all, I want to get 3 pairs. And we did this before, right? But this time I'm going to move this 2x to the other side. So like minus 2x, just for the ease of calculation. So y equals 5 minus 2x is cancelled. Now I just plug in x value to calculate y value. So I let x to be 0, y equal to 5. Then I let x equal to 1. 2 times minus 2, right? 5 minus 2, 3. Now I let x equals to negative 2. Negative 2 is not a good idea because I don't have enough the labelings to indicate the number. So let's do positive again. I let x equal be 4. Yeah, 5 minus 8 is negative 3. Now I get 3 points. I'm going to use 3 points. I'm going to use a pencil just in case I made some mistake in calculation, right? So 0, 5, x is 0, y is 5. X is 1, y equals 3. And x equal to 4, y equal negative 3, 4, negative 3. Oh, here's negative 1, 2, 3. They're supposed to be on the same line. Look at that. Yeah. That's the graph. Okay, now we have another example down here. Graph this one. Let me see if I have more room on the next page. Yes, I'm going to copy this to the next page. Y equals 1/3 x minus 5. So y equals 1/3 of x minus 5. So we're going to choose those x values and that are multiple of 3 so that we have whole numbers to draw, right? So I let x equal to 3. I can let x equal to 0 again, actually, but let x equal to 3. 1/3 of 3 is 1. 1 minus 5, that's negative 4. X equals 0, y is negative 5. Now let's do another one. Let's do 6. X equals 6. Do I say, yeah, I have 6. X equals 6. 1/3 of 6 is 2. 2 minus 5, that's negative 3. Now let's draw these 3 points. 3, negative 4. 3, negative 4, that's here. And 0, negative 5, that's here. 6 and negative 3. 6 and negative 3, that's here. Are they on the same line? Looks like. Yeah, that's the line. Basically, this line, this equation are the same thing. They represent same relation between x and y. Y is in equation or algebraic format, y is in visual format or graph format. They represent the same relation. That's why a solution, which is a point in graph, a solution pair to the equation will be a point on the line. Because the line is a solution line. All of the point on the line is a solution. Okay, now let's look at the next learning objective. We're going to graph horizontal and vertical lines. So we graph 2 lines already, right? This is a special case. Say the first one, we are going to graph y equal to 3. You'll notice that we only have one variable y without x in it. What does it mean without x? Without x means x doesn't make any difference. That's why we don't need it. So if you want to see a full version of this, I can put x in it. Like 0 times x plus y equals 3. Can you see that? This is equivalent to that. Because no matter what you have for x, 0 times that is cancelled. you still have same thing. That's why x value doesn't matter. Now, why x value doesn't matter, what that imply? X goes horizontally. Can you see that? It means horizontally, X can be any value. In other words, this graph horizontally, you're free to go. Can be anywhere horizontally. But Y value, well, given Y has to be equal to 3. That means you cannot change Y value. Y has to be 3. What's the direction of Y? Y is vertical. That means vertically you cannot move. If you move, it's not 3 anymore. This is the 3 level for Y. You cannot go up, you cannot go down, you cannot go down. Either way, you're going to change Y value. But X value can be anything. That means horizontally, you're free to go. So as a result, you can only go freely horizontally. That means you're going to get a horizontal line. So this is a horizontal line when you have a fixed Y value. But if you're not sure by this explanation, we can give you 3 points. You already see X doesn't matter, X can be any value, but Y has to be 3. X equal 2, Y equal 3. X equal 0, Y equal 3. X equal -3, Y equal 3. Let's draw those. X equal 2, Y equal 3. X equal 0, Y equal 3. X equal -3, Y equal 3. We get the horizontal line? Yeah. But understanding it intuitively is way better than just following steps. Y is fixed. You cannot go up and down. You can only go horizontally. That's why we have a horizontal line. Now let's look at the other one, B, X equals 2. In this case, X value is fixed. Remember, X goes horizontally, right? Horizontally, you have to add this point at this value 2. You cannot go horizontally, really. But Y is not part of it. That means Y doesn't matter. Y can be any number, doesn't make any difference. So vertically, you're free to go. Horizontally, you're fixed. So you're going to get vertical lines. So let's look at this. We get X equals 2. If you give 3 points, since Y doesn't matter, again, I can rewrite this as X plus 0Y. 0 times Y equals 2. So Y can be any value. Doesn't make any difference. X is 2, Y is 2, X is 2, Y is 0, X is 2, Y is -5. Just give different Y values. X has to be fixed. 2 and 2, and 2 and 0, 2 and -5 is here. So certainly we're going to get a vertical line, right? Makes sense. No. Because Y is free to go. Y is a vertical direction. X has to be at 2 level, cannot go to the left, cannot go to the right, because otherwise you're going to change X value. Now, the last part for this video, if you're given an equation, how do we find the coordinates of the X and Y intercept? First of all, understand the concept. This is a coordinate system. With Y and X, you will have a line. It will intercept with this 2 axes at these 2 different points. This is X interception point, this Y interception point. We want to locate these 2 points, coordinates of these 2 points, given an equation. How do we find these 2 points without graphing from an equation? Actually, logically, it's very easy to do, because a linear equation with a graph is a straight line. We know they're going to intercept with these 2 axes. But we also need to know the characteristic of these 2 points. These 2 points are special. It's not upon any random point. These points are on axis, x-axis, and y-axis. For any point on x-axis, y value is 0. Because if y is positive, it will be above this line. If y is negative, it will be below this line. It's on this line, so y has to be 0. And there's only one point on this whole line whose y value is 0. That's here. In a similar manner, for y-intercept, there's only one point on this whole line whose x value is 0. Look at this point. If you have other points, all of this x value are going to be negative, right? All of other points whose x value will be positive. Only the point, intersection point on y-axis whose x value is 0. So knowing this, that's our weapon, basically. We can locate these 2 points because these 2 points are special points. Now let's look at the first one. To find the y-intercept, let me use a pen. We let x value to be 0 because only on this whole line, only one point whose x value is 0. That's y-intercept. That's why we just let x to be 0. X is 0. This is gone. So we get negative 4y equals 12. So 12 divided by negative 4, y is negative 3. So that's y-intercept coordinates 0, negative 3. Now in a similar manner to find x-intercept, we just let y value to be 0 for the same reason. We just let y value to be 0. So if y is 0, this whole y term is gone. We get 3x equals 12. We divide by 3 on both sides, x equals 4. So we get 4, 0. So this is our y-intercept, this is our x-intercept. But this is the final answer. But after we have this example, we can summarize this whole process, and actually we can make this whole thing a lot faster, easier than this. This is not hard to do in the first place, but we can make it even easier. Imagine that, yet not imagine that. It's just look at this fact. In the last step, how we get y value of this y-intercept. I use 12 divided by negative 4. Look at this equation. Where is 12? Where is negative 4? Basically, y value of the y-interception point is just use this number on the right divided by the number in front of y. Similarly, last step, we use 12 divided by 3 to get x value for x-intercept. Where is the 12? Where is the 3? So we just use the number on the right-hand side divided by the number in front of x to get x-intercept value. Knowing that, next is if we have similar problem, similar problem means x, y on one side, a number on the other side. Similar structure. All you need is to do 2 simple divisions. So let's look at our next one. And the next one, we don't have that structure. I mean, the special structure x, y on one side, number on the other side. But still, we can use the basic knowledge to do that. So first, to get x-intercept, y has to be 0, right? So let y equal to 0. So let y to be 0, then 0 equals 3/4 x. Solve for x, x equal to 0. So x-intercept is 0, 0. How about y-intercept? For y-intercept, you let x to be 0. X is 0, y also 0. So the same thing. And this makes sense if you do the graph looks like this. You don't have to graph like this. They only intersect with both x and y at the same point. That's origin. That's why you have these two the same. Now this one, x equals -5. And you can do it by drawing the graph. You can do it by just looking at the equation using basics. So for x-intercept, you let y to be 0. But y is not involved. Y can be any number. X always -5, which means if y equal to 0, x also equal to -5. So -5, 0. This is x-intercept. How about y-intercept? Y-intercept means you let x to be 0. But if this one says, particularly this one says x equals -5, that means x cannot be 0. That means y-intercept doesn't exist. Actually, this makes sense if you draw the graph. If you look at the graph of this one said x equals -5. Suppose this point is -5. That's your line, it's vertical line. Sure, we don't have y-intercept. You only intercept with x-axis. Now the last one, y equals 7. So to find x-intercept, we let y equal to 0, right? We let x, because y has to be 0 to have x-intercept. But this one says y equal to 7. That means y cannot be 0. Y cannot be anything else. So that means this doesn't exist. Now to find the y-intercept, we let x to be 0. We can do that because x is not a part of it, only means x doesn't make any difference. X can be any value, but it doesn't make a difference. So for when x equals 0, y will be 7. When x equals 10, y also 7. But for the intercept, for the y-intercept, x has to be 0. So y equals 7. So that's our intercept, 0, 7. And as a matter of fact, it can be confirmed by this graph. So this y equal to 7, suppose this point is 7, it's horizontal line. X doesn't matter, y always 7. Sure, it doesn't have x-intercept. Makes sense, right? And that's the last video for this whole course. Please let me know if you have any ideas or any suggestions, any comments. Yeah, put it in the comment area. I appreciate that. Bye.